Everyone, let's solve some Leetcode today. So today we have Leetcode 310, that is minimum height trees. Now this problem is definitely hard for a medium problem. In this problem your observation skills have been tested. So in this problem we have been given n nodes with n-1 edges between them, which is a very special number. It means that we are given a tree, and we have also been given an array of n-1 edges. So this means that we are dealing with graphs, and trees are basically graphs if you actually make them bidirectional. So they are basically graphs. So each element in the array of edges contains two things, A and B, where we are denoting that edge between A to B and B to A as an undirected edge. So it means we have bidirectional edges. We can go from A to B and we can go from B to A. Now when you select a node X as the root, the resulting tree will have a height edge. So that makes sense, right? If I select 0, I have a height. If I select 1, I still have a height. If I select 2, I still have a height, right? So the resulting tree will definitely have a height no matter what root we choose. Now here is the interesting thing. It is saying among all the possible rooted trees, we have to return the roots of the trees that have the minimum height. So here we can see that we have many trees, right? We have the same nodes 0, 1, 2 and 3, but depending on which node we choose, we get a different tree, right? So if we choose 0, we have a height of 1, 2. So height is 2 here. If we choose 1, the height is 1. If we choose 2 here, then the height of the resulting tree will be 1 and 2. If we choose 3 here, then also the height of the resulting tree will be 1 and 2. So the minimum height was 1 in this case for this particular rooted tree. And it is because on the longest path from 1 to any leaf node, we have only one node. That's why the height was 1. And that is why it is called minimum height tree, because it is minimizing the height of the tree. In all other cases, the height is 2, that is more than the 1. And that is why this is the only tree which is minimizing the height to 1. Now we have to return the list of MHT or minimum height trees root labels. It means that we have to return this. As you can see that here is only one tree that minimizes the height. So we have to return 1 in a list. So here you can see that output is 1. In case we had some other tree with a height of 1, then we would also take that root and add in this array and return it. So it means that there can be multiple root nodes that actually lead to the same height, and we have to return a list of those nodes. Now from the context given in the question, we can figure out a way of brute force. Since we actually have to figure out the height of the trees, why not just do that? Why not just take each and every node from the given nodes and we calculate the height of the tree resulting from that nodes, and then we simply store the nodes like 1, which results in the minimum height, and then simply return that. We can do that, correct? But here's the big issue. We have n nodes, and to find the height we will eventually have to traverse through all the nodes in a particular tree, right? So we will going through n nodes in a particular tree. So it means the n nodes will create n trees, and in each tree we have to traverse n nodes. So it means for n trees we are traversing n nodes, which is going to give us n square time complexity. And of course this is not optimal. We can definitely do better. Now for these kind of questions which are actually in the category of hard, what we are actually trying to test is your observational skills. So in order to solve this question, we can start with the simplest case and try to observe what is happening. Let us start with the simplest case of having one node. What is the height of this node? 0. The height of this node is 0, right? Why? Because there is no other edge going on from here. So the height is 0. Now since there is one node, we can simply return this particular node. Suppose the node is A. So I simply return A. Now what if I actually add another node B? Now what is the height of this tree? If you take this node A as root node, the height is 1. If you take B as root node, the height is still 1. So it means the minimum height for this case is 1. And no matter from where you go, either you go from A to B or B to A, the height is going to be 1. So you can simply send A comma B back, because for both the root nodes, the resulting tree height is 1. Now suppose we add one more. See here. Now what is the resulting height? Well, if we go from here, then we have 1, then we have 2. So the height from here is 2. If we go from here, the height is 1 and then 2. So it means the height from here is 2. But what about A? If we try to go from A, then we have a height of 1 here and then 1 here. So it means that the minimum height here is 1. So what we will do is we will simply return A. Now what about this case? If we try to go from C, then the height will be 1, 2 and 3, correct? So the height will be 3 for here. Similarly, the height for D is going to be 1, 2 and 3. Now the height from B is going to be 1 and 2, because this is the longest path from B. So the height from B is 2. Similarly, the height from A is going to be 1 and 2, because this is the longest path from A. So the height is going to be 2. So it means we are going to return these two. These two will be the answer in our array. So A comma B. So till now we can see a pattern. First of all is that when we actually had just 0 elements, when we had only one node, we actually just send one, right? When we had 2 nodes, we send two. When we had 3 nodes, we send again one element. And now when we have 4 nodes, we are sending back only 2 elements. So we can see some sort of pattern. So let us try to go for one more example. So if I try to go from E, I will have 1, 2, 3, and 4 nodes. So I will have a height of 4 from E. From C also, I will have a height of 4 because of symmetry. 1, 2, 3, and 4. Then from A, I will have a height of what? 1, 2, 3. So A will have a height of 3. Similarly, D will have a height of 3. 1, 2, 3. Now B, what is the height from B? If we go from here to here, then we will have a height of 2. 1, 2. So it is going to have a height of 2 from here to here. And on this branch also we have a height of 2, 1, 2. So the minimum height right now is 2. So it means we only have one minimum height tree in which the root is going to be the B. So we will simply return B, and which means we are again sending one element. So we can see a pattern now. As long as there are odd number of nodes, 1, 2, 3, 4, 5, the middle node is going to be the MHT or minimum height tree. So we are only going to send one. But if there are even number of nodes, 1, 2, 3, and 4, the middle two are going to have the same height, and so we are going to send 2 nodes. But what will happen if I start adding edges like this? F. Now what? Well, if I try to calculate the heights, from E the height is 1, 2, 3, 4, or 1, 2, 3, and then 4. So the height is going to be 4. From A the height is going to be 1, 2, or 1, 2, 3, and 4. So the maximum number we can get is 4. So the height is going to be 4. From B, what will be the height? Well, 1, 2, 3 on the longest path. So it is going to be 3. From D, what is going to be the height? 1, 2, 3, or 1, 2, 3. So the height from D is going to be 3. Now what will be the height from C? Well, it is going to be 1, 2, or 1, 2, or 1, 2. So it is going to be the 2. And still we get the C as our answer. So we will simply return C in the array because C has the minimum height. But what if? What if we add more nodes? I add G here. Then what will happen? The height from E will be 1, 2, 3, 4, 5. The height from A will be 1, 2, 3, 4 in this branch, or 1, 2, 3. So 4 is bigger, so we will take 4. The height we will get if we take B as a root node is 1, 2, 3, or 1, 2, or 1. So 3 is the larger number, so height will be 3. What will be the height from D as a root node? Well, we have 1, 2, 3, 4, or 1, 2, 3, or 1. Since we are having 1, 2, 3, 4 as bigger number, so I will simply say 4 here. And now let us figure out what is the height from C. So we have 1, 2. Then we have 1, 2, 3. Then we have 1, 2. So it means the height from C is 3. And there are 2 nodes that actually result in the same height, B and C. So we are going to return B, comma C. So now one thing to notice is that we are either returning one element or we are returning 2 elements each time. So that we can take from the observation that we will either have one element in the answer or 2 elements. Now all we have to figure out is which one are going to be the one element and 2 element. Now if we look at this particular tree, you will realize that when we did not have this particular node, or the longest length was actually this one. From A to E was the longest path, right? But as soon as we added this particular node, the G node, the longest path became this. So in earlier case, when G was not here, the longest path had 1, 2, 3, 4, 5 nodes. But as soon as we added G, the longest path had 6 nodes. And as soon as the longest path became 6 nodes long, we got 2 nodes as our answer. But when it was just 5, we only got C as an answer, that is 1 node. And you can see that each time the elements or the answer that we are returning are actually part of this longest path. C was part of the previous longest path, and B and C are part of the new longest path. So it means we can assume that the answer is always going to be along the longest path. And we are going to make these assumptions based on observation, because most of the time when you are solving questions in the interview, you don't actually have time to go ahead and deal with all the mathematical proofs. So now based on this observation, we will try to find how we can figure out this B and C. So now in order to figure out this B and C, we need to figure out this entire longest path, right? If we can figure out the nodes on this longest path, we will have our B and C. But the question is, how do we figure out the longest path? Because we will not know from which node to start. We can start from any random node. But I know that if I take the E node and I try to find the maximum height from E, then I will eventually lead to this particular path, because that is the maximum height. Now the question is, how do I reach till the E node or the leaf node from which I can find the maximum? So what we can try to do is we can try to figure out the height from different nodes. If I try to go from here, I will reach 1, 2, 3, 4, or 1, 2, 3, right? So I can reach E if I try to find the maximum height from A, if I try to find the maximum height from B, I will reach 1, 2, 3 or 1, 2. So I can still again reach E from B. Similarly, if I try to find the C, then I will reach 1, 2 and 1, 2, 3. So I will reach G node, right? And that is fine. Why? Because G node is also part of the longest path. So if I start from the G node and try to find the maximum path, I will find all these nodes in that path. So it means I just need to get one of the leaf node in the longest path and I will be able to figure out the longest path and the nodes in it. So now if we try to find the maximum height from D, so yes, starting from D also we can reach this particular node as the maximum height. So what will happen if I had an extra node M? So I can start from here 1, 2, 3, 4 or 1, 2, 3 or basically 1, 2, 3. So I'm getting 3, 3 and then 4 height. So I will take the fourth one. So 1, 2, 3, 4. So it means even from N node, I will reach the G node. So on observation, we can see that from any random node, if I try to find the maximum depth or if I try to find the maximum height, I will reach one of these leaf nodes. Why? Because they are part of the global maximum. Since they are part of the global maximum, they will always be the part of local maximum also. So I can simply take any random node and find this G or E. Any of these nodes will work. Now once we get a hold of G or E from any given random node, what we can do is we can simply run DFS from G or E and we find the maximum height path from G or E because both of these paths will contain all the nodes from here to here. And once we find all these nodes, we can store these nodes in an array. So if I start from G, I can store G, F, B, C, then we have D and E. So I stored all the nodes on the global maximum path and now all I need to do is find the length of this array. So 1, 2, 3, 4, 5, 6. 6 is the length which is even. So it means I just need to take these middle elements and then just return them. If we did not had G in the graph and we only had these elements, then we can simply return the middle C. Why? Because F, B, C, D and E are actually 5 nodes. So length will be 5. It means I just need to return 1 and that one is going to be the middle element. So this is basically how you can solve this question. And yes, there are other ways to solve this question also. But I went through an approach that felt most intuitive to me. Something that I can do in an interview also if I just try to use my observational skills. Now yes, I will be honest with you guys. I was not able to figure out the solution by myself in the first try. So yeah, this is a hard problem. It's just labeled as medium, but it's actually a hard problem. So now let us look at the code. Now please understand that I'm assuming you know how DFS works and how to actually find the path or the nodes on the path with the help of DFS. Because this is the prerequisite knowledge that you will need to solve this particular question. And now we can go through the code. So here in the first function DFS, all I'm doing is that I'm taking a source node and then I'm returning the nodes on the longest path from this particular source node. So this DFS function is basically used to find the nodes on the longest path from a given node. And now here we are basically creating the adjacency list because we have been given a graph in the form of a tree. So we will need adjacency list here. And since it is a bidirectional graph, I'm adding an edge from U to V and I'm adding an edge from V to U. And now we are taking a random node to find the longest path locally. So it means this line will help us find the E or the G node that we were talking about in the drawing explanation. So we will find the local path and this local path will have a leaf node that will be part of the global maximum. And the leaf node that we are looking for will be at the end of the path. And that is why we are taking the last element from this array. And now since we have this end node, we will use the DFS on this end node to find the maximum or the longest path from this end node. The longest path from this end node will be the global longest path as we already discussed in our observations. And once we get all the nodes in the path, we will take the count, how many nodes are there, and then we will check. If the count is even, it means the number of nodes are even. We will return the middle two elements like this. But in case the count was odd, we will simply return the middle element, the middle single element. And that is how, my friends, we can solve this particular question. So now let us run this thing and see what happens. So yeah, all of our 71 test cases are passing in the time limit. We are running in 931 milliseconds. And yes, there can be other solutions which are like very optimized. But the solution that we discussed here is based on pure observational knowledge. And that is what you will be relying on when you're going for interviews or when you're just solving these kind of problems on the go. So yeah, now we can go for time and space complexity analysis. So the time complexity is order of n, and that is because we are using the DFS function to find the nodes on the longest path. Yes, of course, we are using the DFS function 2 times, so it should be 2 multiplied by n. But in case of big O notation, we simply drop this constant and we simply take the variable that is n. That's why we have order of n. Now in terms of space complexity, since we are using recursion, we will have a call stack, and also we are creating arrays to store the nodes from the path that we are getting from this TFS function. So that's why the space complexity is order of n, because in the worst case scenario, we might end up storing all the elements that are present in the graph into our array. And this worst case can happen when you have a graph like this. Everything is just sequentially connected like a linked list. So these kind of things, can give you a worst case time complexity of order of n, because you will actually end up storing A to E, all of these nodes in the array, because they are part of the longest path in the tree. So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, then just let me know in the comments. Now we will meet in the next video. Till then, bye.